So today we're doing a full walkthrough of Chem 100 Laboratory 9, which focuses on properties of solutions, and specifically the idea of solutions, colloids, and suspensions. So first and foremost, all of the Laboratory 9 materials are found in the Laboratory 9 module titled Properties of Solutions. The first thing I'd like to draw your attention to is the introductory page, which talks about the learning objectives for this laboratory that I would encourage you to read on your own time. The next thing I want to draw your attention to are the Laboratory 9 procedure and report sheets available in Word and PDF formats. You're going to want to download or print out these procedure and report sheets, as we'll be filling them in as part of completing today's laboratory. The next thing I'd like to draw your attention to is the Laboratory 9 Canvas page titled Laboratory 9 Properties of Solutions. In addition to having all of the photos and videos that we'll be using to collect data and observations needed to complete our report, the Lab 9 page also has a wealth of detailed information on the theory covering today's laboratory. So I'd encourage you to read the introduction section of this laboratory on your own time. You'll also want to have this laboratory page open as we will be discussing the videos and photos provided as part of completing today's lab. The next thing I'd like to draw your attention to is the pre-lab lecture, which contains some background information necessary to understand the theory behind today's lab. The other thing I'd like to draw your attention to is the lab walkthrough video titled Laboratory 9 Laboratory Recordings, Video Walkthrough to Complete the Experiment 9 Virtual Laboratory. This is the page containing the video that you're watching right now. Finally, I'd like you to draw your attention to the laboratory report submission page. This is where you'll be submitting your complete report once you finish the lab today. Okay, so with that out of the way, let's now get started with going through the lab. Here are the procedure and report sheets for experiment 9. And before we start the lab, we have the pre-lab checklist. So we're going to open the lab page, read the background reading, watch the pre-lab lecture, and if you haven't already, you'll open up the laboratory recording page containing the laboratory recording video. This is the video that you're watching right now, where we go through the lab together and complete the lab procedure and report sheets together. As always, if you're asked to view a video or photo in Canvas, all videos for this experiment are found in the Canvas page for Laboratory 9. So let's get started with the procedure now. So in this lab, as a broad overview, we're going to be determining whether various solution components are classified as solutes, colloids, or suspensions. And one of the ways that we're going to detect whether a solution component is present or absent in a solution sample is via chemical tests. So in Canvas, we're going to view a video showcasing positive results for the silver nitrate, iodine, and Benedict's reagent chemical tests. You're going to observe the positive result for the silver nitrate test, which tests for chloride, that occurs when we mix silver nitrate solution with a chloride solution. You're going to observe the positive result for the iodine test for starch, that occurs when the iodine solution is mixed with the starch solution. Finally, you're going to observe the positive result for the Benedict's reagent test for glucose, that occurs when a solution of Benedict's reagent is mixed with a glucose solution and then heated. The Canvas video that we're going to watch showcases the following procedure, where 1 to 2 mils of sodium chloride is treated with a solution of silver nitrate and agitated. The chemical reaction is observed, and the positive test result for chloride is observed and recorded. For the next test, for starch, 1 to 2 milliliters of a 1% starch solution is treated with a solution of iodine and agitated. The chemical reaction is observed, and the positive test result for starch is observed and recorded. Finally, for the test for glucose, 1 to 2 mils of a glucose solution is treated with a solution of Benedict's reagent. The solution is heated in a boiling water bath the chemical reaction is observed, and the positive test for glucose is observed and recorded. Okay, so in our procedure, we're going to watch the video for part A. We're going to observe the positive test results for chloride. We're going to observe the positive test results for the starch solution, and we're going to observe the positive test results for glucose. Okay, so let's take a look. So here we go. Here's the silver nitrate test for chloride. So silver nitrate is being very carefully added to the sodium chloride solution. And as we can see, almost immediately, as the solution is agitated, we can see a very clear generation of the white solid silver chloride. So for our positive test result, we can very clearly see a white solid. So that's what the positive test result looks like for chloride. We see a white solid precipitate. Okay, let's keep watching now and let's observe the starch iodine test now. So here we're doing a classic test for starch, and we're treating that starch solution with iodine. So here's the iodine, here's the 1% starch. We add a drop of iodine, and we immediately see a color change. This is the formation of the characteristic blue-black starch iodine complex. So we see a dark blue color. So let's write that down. So for the starch test, we see a dark blue color when we test for starch using iodine. Okay, so that's what the positive test result looks like for starch. So if we treat a solution with iodine and we see this blue color, it likely has starch in it. Finally, we have a 10% glucose solution and we're treating it with Benedict's solution. That's that blue solution that we're adding. So we're treating the glucose solution with Benedict's reagent. And now this reaction requires you to heat it in order for you to see what the positive test result looks like. So we're going to mix these solutions together and then we're going to heat it in a boiling water bath. So here's a boiling water bath. We're going to let this sit in the boiling water bath and then we're going to observe the final results. After some time passes, here's what the positive test result looks like for glucose. As you can see, it's sort of a brick orange red color. So a positive test result for glucose with Benedict's reagent yields an orange color. Okay, so these are the positive test results. You're going to keep these in mind for later because we're going to be doing these chemical tests throughout this laboratory. Okay, let's talk about part B, separating solutions, colloids, and suspensions via dialysis and filtration. So in this next part, we're going to be taking a mixture containing chloride, starch, and glucose, and we're going to be subjecting that mixture to dialysis. So dialysis is used to separate colloids that are too large to pass through the dialysis membrane from solution components. Generally, if a solution component cannot pass through a dialysis membrane, it's considered a colloid. The components that can pass through a dialysis membrane are considered solution components or solutes. So what we're going to do is we're going to make a solution containing chloride, starch, and glucose, and we're going to load this solution into a dialysis bag. A beaker of deionized water is going to be prepared, and we're going to place and we're going to test the deionized water in this beaker for chloride, glucose, and starch. This is known as the 0-minute test. Note, because we just put deionized water in this beaker that we prepared, we should not see any positive test results for the deionized water. The deionized water in the beaker is just used as a negative control. Now, the dialysis bag is going to be filled with the chloride, starch, and glucose solution, and we're going to place that sealed dialysis bag into the beaker containing deionized water. We're then going to set a timer for 30 minutes, and dialysis is going to be allowed to occur over 30 minutes. Over this time, the solution components will pass through the dialysis bag membrane and enter the deionized water in the beaker. After 30 minutes, we're going to test the water inside the beaker for chloride, glucose, and starch. And this 30-minute test will let us determine what solution components passed through the dialysis bag and ended up in the water that's held in the beaker. The dialysis bag is also going to be emptied into a separate container, and the solution inside that separate container is going to be tested for chloride, glucose, and starch. Any components that remain in the dialysis bag are colloids that could not pass through the dialysis membrane. From this information, we can classify chloride, glucose, and starch as solutions, colloids, or suspensions. So, here's the procedure that we're going to be seeing in the video. A solution containing 10 mils of sodium chloride, starch, and glucose solution is prepared and loaded into a dialysis bag. A 100 ml beaker is filled with deionized water, and that deionized water is tested for chloride, glucose, and starch. We're going to record our observations for those chemical tests. The dialysis bag is then sealed and placed into the beaker containing deionized water. A timer is going to be set for 30 minutes, and dialysis is allowed to proceed for 30 minutes. After 30 minutes, the water inside the beaker is tested for chloride, glucose, and starch. We're also going to test the dialysis bag solution by emptying the dialysis bag into a separate beaker and testing that dialysis bag solution for chloride, glucose, and starch. We're going to write down the results of the chemical tests, and from this information, we can determine if chloride, glucose, and starch can be classified as solutions, colloids, or suspensions. Okay, so in our procedure, we're going to watch the video. We're going to observe how the dialysis bag solution is prepared. We're going to observe the deionized water solution placed in the beaker. And then we're going to observe as the deionized water solution is tested for chloride, glucose, and starch, and record our observations of the chemical tests for the beaker water after 30 minutes of dialysis. Sorry, after 0 minutes of dialysis. So this is our negative control. Just before anything's happened, what does the deionized water in the beaker test for? We're then going to watch as the dialysis bag is placed into the deionized water and time is allowed to elapse for 30 minutes. We're then going to observe as the water solution in the beaker after 30 minutes is tested for chloride, glucose, and starch. We're going to record our observations of the chemical tests for the beaker water after 30 minutes of dialysis. We're then going to observe as the dialysis bag is emptied and observe as the solution inside the dialysis bag is tested for chloride, glucose, and starch. We're going to record our observations of the chemical tests for the dialysis bag solution. Okay, so that's our run through. So let's now just write down our chemical test observations based on the video. So here's the dialysis. So let's take a look and let's watch this video in detail. I would encourage you to watch this video on your own time with the narration on, as it has a lot of useful information. We're going to skip ahead to when they actually start performing the procedure. Okay, so here's the sodium chloride, glucose, and starch solution. They're mixing them all in a beaker. This is what's going to go inside the dialysis bag. So the sodium chloride, glucose, and starch solutions are mixed. Okay, now they're loading that solution into a dialysis bag. So here's the dialysis bag, and here's what the sealed dialysis bag looks like. They're then going to pour deionized water into the beaker. This water has already been tested for time equals 0 minutes. We've tested this deionized water for glucose, starch, and chloride, and we're going to see that in a moment. So now they've set up the dialysis bag. They have a beaker filled with deionized water, and dialysis is proceeding. During this time, we're testing the beaker water at 0 minutes. So here's what the chloride test looks like. We're using silver nitrate. We're testing for chloride. And as you can see, when we tested the deionized water for chloride, do we see any white solid? I don't see much of anything. So I'm going to write down that observation. So the beaker water for 0 minutes. For the chloride test observations, we see no change. And because the test for chloride is negative, what this tells us is chloride is not present in the solution. Okay, let's now take a look at these starch test observations. So we're testing the deionized water that we put in the beaker. We're testing for starch using the classic iodine reagent. We added iodine, we're testing for starch, and do we see that characteristic dark blue color that's a positive test result for starch? No. So we don't really see much of a change. So our test for starch, we see no change. So starch is not present in this solution. This all makes sense. The beaker water is just deionized water. It has nothing in it. So this is all making sense. Okay. Now let's take a look at the last test. We're testing for glucose using Benedict's solution. So we add the Benedict's reagent solution. And remember, we got to heat it. If it's a positive test result, we'll see this brick red, brick orange color, but I don't think we're going to see much of anything because this beaker water is just deionized water. Nonetheless, we'll let it heat. After 5 to 10 minutes of heating, we don't see any change. So this is a negative test result for glucose. So let's write that down. So is glucose present? No. This is great. This is telling us that the deionized water has nothing in it, which is good. Okay. At this point, the dialysis has been running for a fair amount of time. So let's check up on the results of dialysis. So 30 minutes later, we're now going to test the water in the beaker, and we're also going to test the water inside the dialysis bag. We're going to start by testing the water inside the beaker first and foremost. So remember, as dialysis has been allowed to occur, some solution components have passed through the dialysis bag and into this beaker water. We're also now taking the water inside the dialysis bag and we're going to test that as well. So we're trying to figure out what passed through the dialysis bag and what remained stuck in the dialysis bag. Okay, we're now doing the silver nitrate test. So we're going to write down our observations for the silver nitrate test. This is what we're testing right now with the silver nitrate test. As you can see, we have a positive test result for the silver nitrate test. Okay. Now we're going to test with iodine. And what we're testing right now is the water in the beaker. So this is the water in the beaker after 30 minutes of dialysis. So we had a positive test result for chloride. So when we tested with silver nitrate, we saw a positive test result. So for the 30-minute beaker water, we're going to write that we had a positive test result. So for the chloride test observations, we observed a white solid. So chloride was present. Let's take a look at the starch solution now. When we tested for starch using the iodine test reagent, as we can see, when we add the iodine test reagent, we do not observe that characteristic dark blue color, telling us that the water inside the beaker after 30 minutes of dialysis is negative for starch. Let's write that down. So for the starch test, we see no change. Is starch present in the solution? No. Okay, let's now take a look at the glucose test. So we're testing for glucose in the beaker water after 30 minutes using Benedict's reagent. Remember, this reaction requires heating, so we're going to see what happens after we heat the sample. So as you can see, we're observing a minor color change. It's turning slightly red and orange. So that tells us that there's a small amount of glucose, not a ton. So we're going to note that we see a small color change. Is glucose present? Yes, but it's present in relatively trace amounts. Okay, now that we've tested the beaker water after 30 minutes, let's see what's still remaining in the dialysis bag. So let's take a look at the test results for the contents of the dialysis bag at the end of the experiment. So here is the chloride test using silver nitrate. So for the contents of the dialysis bag, we see that characteristic white solid. So for the chloride test, the dialysis bag contents, we observe a white solid. So yes, chloride is present. Okay. Now let's take a look at the starch test results using iodine. So here's the test for starch using the iodine test reagent. As you can see, we see the beautiful dark blue color. So let's write that down. So we see a dark blue color, which tells us starch is still present inside the dialysis bag. Let's take a look at the glucose test observations using Benedict's reagent and heating. We would expect, if it's positive, for us to see that characteristic brick red-orange color. And as you can see, testing for glucose with Benedict's reagent, if we test the liquid inside the dialysis bag, we see a positive test result for glucose. So we see an orange color. That tells us that glucose is present in large amounts. So what does this mean? Well, any species that passes through the dialysis bag is considered a solution component. Based on the chemical test results, we can identify which species passed through the dialysis bag. Any species that is found in the beaker water after 30 minutes must have passed through the dialysis bag. Colloids cannot pass through the dialysis bag membrane. Any species that remains in the dialysis bag must be a colloid. In other words, any species that is not found in the beaker water after 30 minutes of dialysis must be unable to pass through the dialysis bag. So based on this, chloride, as we can see after 30 minutes, does end up in the beaker water. It has passed through the dialysis bag, so we will call chloride a solution component. Starch, on the other hand, could not pass through the dialysis bag. We did not see it in the beaker water after 30 minutes, so we would call starch a colloid. Glucose did pass through the dialysis bag. We saw a little bit of it in the beaker water, but a lot less of it. So you can also call glucose a solution component, but it's much less efficient at passing through the dialysis bag. Okay, let's now talk about part C, which focuses on suspensions and filtration. So in Canvas, you're provided a video showcasing the filtration of a sample containing solid charcoal, chloride, starch, and glucose. You'll observe the video as the sample is filtered, and you'll note what species pass through the filter and what species cannot pass through the filter. The video then showcases how the filtrate solution, which is the liquid that passes through the filter, is tested for chloride, starch, and glucose using the standard silver nitrate test, iodine test, and Benedict's reagent test. Based on your observations of the filtration and chemical tests, you'll be able to identify if charcoal powder is a solution, colloid, or suspension. So in the procedure, you're going to observe the appearance of the solution containing the sodium chloride, starch, and glucose solution mixed with solid charcoal. You're going to pay special attention to the filter paper as the solution is filtered, and you're going to record your observation for the appearance of the filter paper before filtration and after filtration. And you're going to answer the question, what species, what component remains on the filter paper? You're also going to observe the filtrate solution after the sample is filtered. How has the appearance of the liquid solution changed? You're also going to observe as the filtrate solution is tested, and you're going to observe the chemical test results for chloride, starch, and glucose, and you're going to record your observations for each chemical test. Additionally, based on your observations, you're going to tell me what species cannot pass through the filter paper. Species that cannot pass through the filter paper and can be separated via filtration are considered suspensions. And based on your observations of the chemical tests, what species successfully passed through the filter paper? Okay, so let's take some observations. So here is the video for suspensions and filtration. So I'd encourage you to watch the introduction to this video as it provides a lot of useful information. Let's go on to the actual procedure. So we have activated charcoal, and we're going to mix it with our solution of chloride, glucose, and starch. We're going to note the appearance of this solution. So we see that there are a large amount of charcoal particles and the solution appears black. So the appearance. So we're just going to observe the appearance of this solution, and we're going to pay special attention as we filter the sample. How does the filter paper look after we filter this sample? So we're going to filter this mixture. through a piece of filter paper. So that filter paper is going to be folded so that it fits inside our filter funnel. Here we go. So we prepared our piece of filter paper. Now we've set up our filter funnel. And now what we're going to do is we're going to filter our mixture containing charcoal, chloride, glucose, and starch through the filter paper. And we're going to allow the filtration to proceed. As you notice, the solution we're filtering is black due to the suspended charcoal particles. But as we notice, after passing through the filter, the solution is clear. So something is getting trapped on the filter, and you're going to tell me what that is. So the filtration is going to be allowed to proceed. Still going, takes a while. After several minutes, as you can notice, the solution after it passes through the filter is clear, while the solution before filtration is a black color. After several more minutes, let's take a look at our filter paper and let's see what we can see. As we can see, the filter paper has been covered in the black solid. The appearance of the filter paper after filtration, it's covered in the black charcoal particles. Okay, so what species is present on the filter paper? The charcoal appears to be trapped by the filter paper. We can tell that as well because the solution, after it passes through the filter, is completely colorless. So as you can see, we could use filtration to separate the charcoal from the other components. Now, just to make sure that nothing else was trapped by the filter, we're going to do the chemical tests on the filtrate liquid. First is the chloride test for using silver nitrate. As you can see, when we treated the filtrate liquid with silver nitrate to test for chloride, we immediately see a white solid precipitate, which is a positive test result for chloride. So chloride test observations, we observe a white solid, so chloride is in fact present in the filtrate solution. Okay, let's take a look at the starch test using the iodine test reagent. So we add iodine. If starch is present, we would expect to see the blue-black starch iodine complex. And as you can see, we immediately observe the characteristic dark blue color, telling us the filtrate solution does in fact have starch. So we see a blue color. So starch must be present. Okay, let's take a look at the glucose test now. So here we're going to test our filtrate solution for glucose using Benedict's reagent. So we're going to mix these solutions together and then we're going to heat the solution for about 5 to 10 minutes in a boiling water bath. So we're going to let it heat for about 5 to 10 minutes. If this test is positive for glucose, we should expect to see the brick red color, which in fact we do. We see that characteristic red-orange color, which tells us that yes, glucose is present. So based on all of these observations that we've collected, we're going to classify each species as a solution, colloid, or suspension. So chloride is a solution component. Starch, we established previously, was a colloid. Glucose is a solution component, and charcoal is a suspension. Charcoal is a suspension because it could be separated via filtration. It got trapped on the filter paper. Okay, So with that, we've filled out all of the report sheets for this lab. Again, you'll be submitting your report sheets to the Laboratory 9 report submission page on Canvas. When you open the assignment, there will be a file upload link for you to upload your report sheets as a JPEG, Word, or PDF file format. So that concludes our overview of Laboratory 9, and we'll discuss the future labs in an upcoming video.